Hello everyone. In this video, we're going to be solving an interesting homemade functional equation. I call it homemade because I came up with this idea, but I think anyone can come up with the idea. Especially when you see the solution, you're hopefully going to agree with me and hopefully attempt problems like these. And let me know if you find a good problem. Now, we're given two functions, f and g, such that f of g of 2x plus 1 minus x is equal to x squared and g of 3 minus g of 5 is equal to 1. So we're given a functional equation with two functions, and then we're given some numerical value like this, and then we're supposed to evaluate another numerical value. What is that supposed to mean? Does that mean we have to find f and g? Let's go ahead and take a look. The first approach is actually going to look for that, and there's a good reason behind it, but I can't tell you what it is. You need to guess. So here's what we're going to do. First of all, f of something is equal to x squared. Could that mean f is a quadratic function? Well, as long as f is a polynomial, nobody said that, did they? But we're just going to make some assumptions, okay? So suppose, usually most proofs start with that, right? But of course, this is not a proof by any means. But we're just saying, okay, let's make an assumption. Suppose f is quadratic. What does that mean? That means f of x can be written as ax squared plus bx plus c. Great. How does that help? Well, if you plug in something into f and you get x squared, that kind of makes sense as long as this expression is linear. Why is that important? Because if that expression inside the parentheses is not linear, let's say it's x squared, okay? F of x squared will be quartic. You see what I'm saying? Replacing x with x squared in x squared is going to give you x squared squared, which is x to the fourth power. I hope that makes sense. But try it yourself and you'll know what I'm talking about. So we want this to be linear. So that kind of gives us two good things, right? G of something minus x is linear. So does that mean g is linear? Yes. But again, if g is a polynomial. Did anybody say that? No. But we're making an assumption here. So g of 2x minus 1 minus x is linear, like mx plus something. But I can just say that, okay, this means g is linear. So instead of just going through all these variables and crazy stuff, let's just say, suppose g of x can be written as mx plus n. Great. Now, why is this helpful? Because if you look at the equation we're given, like this one, we can just plug it in and hopefully find something from there, which will be helpful. And then we can just plug it into f and hopefully, again, finding something from there. Again, this is just, what we're hoping for. So let's start with this. G of 3 minus g of 5 is 1 because it's given. What is g of 3? You replace x with 3, right? So g of 3 becomes 3m plus n. What is g of 5? G of 5, you replace x with 5, you get 5m plus n. And this difference is equal to 1. It's given, right? And what happens here is n cancels out. Beautiful. That gives us negative 2m equals 1, and m equals negative 1/2. This didn't give us the value of n, but that's okay. We partially solved it. At least we know what m is. Hopefully we can find n, or if we can't, we can still use it. Where? In this equation, the original one, right? So what is it? F of g of 2x plus 1 minus x equals x squared. And also don't lose sight of the goal. We're trying to find f of 5. So if you can find an expression for f of x, can we find f of 5? Yes. First you need to find f of 5, and whatever that is, you kind of have to plug it in, and that'll give you the value. Easy, right? Once you find what f is, and in this case, again, I repeat, f is considered a quadratic function. Now, because we assume that g is linear and we have an expression or equation for g, we can also plug it in here. What is g of 2x plus 1 if g of x is mx plus n, right? Let's go ahead and do that here. G of 2x plus 1, or let's do it here. G of x, that's just notability, being notability. G of x is mx plus n, so we're supposed to find this, right, from here. So what is g of 2x plus 1 minus x? Let's find it first. We're going to replace x with 2x plus 1 to find g of 2x plus 1, right? And that'll give us this minus x. Now, when you simplify this, you're going to get 2mx minus x, so that's 2m minus 1. That is going to be the coefficient of x, plus m plus n. Beautiful. Now, this is what you need to substitute here, right? This is going to go all the way here. So now f of something. Let's go ahead and write it down first, and then we're going to evaluate what it is. F of 2m minus 1x plus m plus n, and that is equal to x squared. Great. Now, notice that we got rid of g, this, which is a good thing. We end up with a single variable. I mean, m and n are variables, but f is what we're trying to find here. So let's go back and use the definition for f. What is f defined as? As this, right? ax squared plus bx plus c. So if, let me put that down here as a side note. Now what we need to do is replace the x with this whole thing, okay? Replace the x with that. I don't know, this way maybe, or that way. So now this becomes f of 2m minus 1x plus m plus n equals, now we're going to replace x with that, 2m minus 1x plus m plus n squared plus b times that. It's not going to fit, so I have to use this area, plus c, right? This is f of g of 2x plus 1 minus x, or f of this, okay? And that is equal to x squared, which is the simplest part, right? X squared. Now you want this whole thing to be x squared, right? How is that possible? Expand and expand and expand. A lot of expansions. And there are 3 variables, but these are 2 polynomials that are equal for all values of x. So we should be able to solve it as a system, okay? Let's go ahead and simplify this first. How do you square something like this? You can treat it like a plus b, or m plus n, or k plus r, whatever. So we need to do the following. First, I'm going to square the first term, this. And then I'll square the second term, which is this, right? Plus 2ab, 2 times, remember the formula, 2ab, a squared, b squared plus 2ab. Okay, good. That takes care of that part. And then, of course, I have to distribute the a all over. And then we distribute the b here. That's going to be like b times 2m minus 1x. By the way, I'm trying to keep these together because I care about the coefficient of x. I don't care about distributing everything. And here I have to distribute the b over this. And then, of course, c is going to be part of the constant term. Okay? So far, so good. Are you still around? Hopefully. You didn't give up, right? So this is equal to x squared. But I'm about to give up because this is too much work. Okay. But here's what's going to happen. We're going to have to distribute this. And this is not too hard, actually, because notice we only have x squared on the right-hand side. And that comes from here. So a times 2m minus 1 squared is supposed to be the coefficient of x squared, which is 1 on the right-hand side. Everything else is kind of secondary. Also focus on the fact that there is no x on the right-hand side. So, oopsies, I didn't mean to do that. This plus this is going to give us the coefficient of x. How does that work? Let's take a look. We get 2 times 2m minus 1 times m plus n as the coefficient of x plus this, which is factorable, by the way. I don't know if you want to do it, is equal to the coefficient of x, which doesn't exist on the right-hand side, which means the coefficient is 0. Make sense? Easy, right? So let's go ahead and factor this because that might be helpful. And then when we do factor it, we get 2m plus 2n plus b, which is super duper nice. Great. Now from here, can we safely say that, m is equal to 1/2? Well, at least if that's 0, doesn't have to be, by the way, because this could be 0 and this may be non-zero. But for now, we know that m equals 1/2. Hopefully is going to work. So we get another equation about m and n. We did. We found m equals -1/2. And here we're finding m equals 1/2. That's a contradiction. So we did proof by contradiction. No, we didn't really prove anything. I think we just proved that f is not going to be quadratic and probably g is not linear either. What is that supposed to mean? This method basically failed because we made a lot of assumptions. And if you assume, you you know what happens, right? Sometimes. Okay, so let's go ahead and look at it from another perspective. I'm going to rewrite the problem so you can hopefully refocus. F of g of 2x plus 1 minus x equals x squared. And we're given g of 3 minus g of 5 is equal to 1. And your goal is to find f of 5. You're probably thinking, hey, there must be an easier way to do it. Yes, there is. And guess what? That's called the second method. The easiest method, okay, most of the time. Great. Now, here's what we're going to do. We're going to go ahead and take a look at this equation and try to make sense of it. Why? Because notice that we have g of 5 here, and we have f of 5. So there's a good reason why we have those, right? What is that supposed to mean? Okay, let me explain this a little bit. You want to get either g of 3 or g of 5 from here. So let's go with numerical values. And this is all an experiment. It doesn't always work the first time. That's perfectly fine. But let's just replace x with 1 on both sides here. So that gives us f of g of 3 minus 1 equals 1 squared, which is 1. Okay, how is this helpful? Who knows? But let's leave it at that and also test. Replace g with 2, because that's also going to give us g of 5 here, right? Which is something we might be able to use. If x is 2, then we get f of g of 5 minus 2 is equal to 2 squared, which is 4. Beautiful. We got two equations. Is that going to help? Not really, because they are different values. Which one should be more helpful? So here's the trick. Take a look at this equation and take a good look. We're given g of 3 minus g of 5, and that's equal to 1. All right, so does that ring a bell? Does that mean we can do something about it? The answer is yes. Why? If you subtract 1 from both sides and add g5, in other words, switch these around, which is a shortcut, by the way, you get g of 3 minus 1 is equal to g of 5. It's just another way of representing the equation that were given to us, so why not use it, right? In a better way. Now take a look at this and take a look at that, and you'll get the idea. Second one is useless, but at least we tried. Who knows, maybe we could have used it. Now, here's what we have so far. What should we do with that, right? So let's go ahead and see if we can use it. Plug it in. G of 3 minus 1 is g of 5, so this is g of 5, right? And from here, we get f of, oh, you know what? I just realized, okay, what I'm going to do is I'm going to change the thumbnail, but the video will be different, unfortunately, but hopefully you'll forgive me. I don't know how I came up with this. But anyways, this is g of 5. I think I should give here f of 5. That would make much more sense, right? Then you could find it. I don't know what happened. But that was the goal. So this gives you f of g of 5, which is what I should be asking for, or change the other one around. I don't know. But f of g of 5 is 1 from this equation. I apologize for the confusion. I wanted to come up with something, but I messed up. But anyways, you're going to see it in full, because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.